Hello everyone, my name is Mustafa and these are my friends Deniz and Ömer. Today we will talk about our term project. In this project, we will try to transmit the data. Data transmission will take place between input and output after pressing the start button. There will be 4 different message types and 4 different buffers to group and transmit them. Inputs will be 4 bits and manually entered to FPGA. The first 2 bits of each buffer will be unique, 00, 01, 10, and 11. Remaining parts, decimal form, will fill the buffers. Buffers will be displayed with different colors and buffer depth will be 6 packets. Also, we have to obey the first in and first out rule. VGA is used for our user interface. For the drop case, if any of the buffers is full and we have the new data for that buffer, we have to drop the oldest data and shift them with one register.
Hi, I'm Deniz. I will talk about the other requirements. Firstly, the first one is the latency requirement. So the latency requirement is actually favors the lowest delay for buffer 1, then buffer 2, then buffer 3, and then buffer 4. If we have a data like this, we needed to read the oldest data of the buffer 1 in term like in this case 1 in order to satisfy the latency requirement. For the reliability requirement, this time we needed to the highest reliability is for buffer 4, then buffer 3, then buffer 2, and buffer 1. And if we have a data like this one, we needed to read the buffer 4 in order to satisfy this reliability requirement. And I will talk about our solution method. Our solution method is based on the combination of 3 parameters in order to determine which buffer needs to be read. And these 3 parameters are the number of packets for each buffer, the reliability parameter, and latency parameter that I talked about. And we actually use the number of packets to determine the dominancy of the latency and reliability. If the number of packets is less or equal to the 3, the half of the capacity of each buffer, that is 6 for our case, the latency becomes more dominant, and otherwise the reliability becomes more dominant. We will use 2 different numbers for 2 cases. And as you can see, this graph actually shows how we calculated the final score. The number of packet score is actually composed of the multiplication of the fullness parameter and the number of packets. And for instance, if we have number of packets that is greater than 3, the reliability score will be dominant, and otherwise the latency score will be dominant, and we will add these scores to reach the final score.
Hi everyone, I'm Ömer and I will talk about our state diagram. At the beginning, we have a start button, and if we press this button, our system will be ready to take inputs. Our input is 4 bits. The first 2 bits is decide which buffer we will store the input at, and the last 2 bits is the value we stored at these buffers. If the first 2 bit is 00, we will store the input at buffer 1, 01 buffer 2, 10 buffer 3, and 11 buffer 4. Every 3 seconds, according to the number of packets and predefined labels and latency parameters, our algorithm will decide which buffer to be read, and in case of the fullness of any buffer, again our algorithm will decide to drop which bit we will be dropping. And that's all. Thank you for listening to us.